Okay, in exercise 26 and also in exercise 28, we're looking at an Excel printout on page 219, and we're to use that to answer the questions. And it says the data comes from one of Mendel's hybridization experiments with peas. The probability of offspring peas having green pods is 3/4 or 0.75. The display lists the probabilities obtained by entering the value of n equals 6 and p equals 0.75. Those probabilities correspond to the number of peas with green pods in a group of 6 offspring peas. So, in number 26, we're to find the probability that at most 5 of the 6 offspring peas have green pods. So as we look at the table when we're talking about most 6, that means x is less than, at most 5, at most 5, that means x is less than or equal to 5. So we have to add up all the probabilities for 0, 1, 2, 3, 4, and 5. Okay, that's one way we could approach the problem. The other way is to recognize there's only one exception, which is the 0.178 that goes with getting 6, all 6 of them having green pods, and that it would be easier to use the complements rule. So x is less than or equal to 5. We could add up the probability of 1, probability of 0, probability of 1, probability of 2, all the way up through the probability of 5, or we can take a shorter approach and apply the complements rule. So we just take the one exception, and that's the 6. It has probability 0.178, and if we subtract that from 1, we get 0.822. Okay, looking at 28, find the probability that 5 or more of the 6 offspring peas will have green pods. Is 5 an unusually high number of offspring peas with green pods? Why or why not? So, probability x is greater than or equal to 5. This time I'm going to add the 2. It's going to be 0 since there's only 2 of them. Okay, plus 0.178. So 0.356 plus 0.178, 0.534. Okay. All right. Is 5 an unusually high number of offspring peas with green pods? And the answer is no, because we look at this, we have over a half is the probability. So certainly it's not less than 0.05. So when it asks, is 5 an unusually high number? The answer is no. Okay, remembering that our probabilities are always between 0 and 1. We have something more than a half. That's a fairly large probability. Okay, now the next one, and in these remaining ones, they tell you to use either the table or the binomial probability. You could use the formula if you want it, or you can use technology. So what I'm going to do is I'm going to use 2 different technologies, one on number 30 and one on number 32, just to show you what you can do with technology. And so we'll begin with number 30, and we're going to do this with the calculator, the TI-84 calculator. Based on a Comcast survey, there's an 80% or 0.8 probability that a randomly selected adult will watch primetime TV live instead of online. Okay. Assume that 7 adults are randomly selected and find the indicated probability. So our probability of success is 0.8. We have N is 7. Okay, and in part A, we want exactly 2. Okay, so we're going to go to our calculator. This, I believe, is one we probably could find in the table, but I'm going to show you how to do it with the calculator. Alright, first of all, what we want to do is we want to do second vars to get into distributions. Now, if we scroll down, we have 2 binomial distributions. The first one is the binomial probability distribution, and the second one is the cumulative. So in other words, it's going to add from 0 up to whatever you're entering as x. Now the directions for using the calculator are on page 217 in the textbook. So if you want to check out any additional information on that, it is on page 217. I'm going to actually use part A, and so I need to go up. I always forget that I have to move up, and I'm going to enter. Now, what you enter when you're using the PDF is you enter your N, your P, and your X. And I just checked to make sure I had those in the right order. So I want to enter my N, my P, and my X. So as I look back, N is 7, P is 0.8, and X is 2. So 7, 0.8, and 2. So I'm going to enter 7, comma, 0.8, comma, and I want exactly 2. That's my x. And I press enter, I get 0.00430. 0.00430. Alright, so let me put this on my... And the book does give both answers. It gives it, if you're doing it with a table, you're going to get 0.004. If you're doing it with technology, you get the 0.00430 that we got. Alright, part B, find the probability that exactly one of the selected adults watches Prime TV live. So let's go back to... The only difference is now x is 1. So I want to go back to the calculator. And again, I want second vars to get... And okay, and we're going to use exactly the same one. Alright, so we have 7, comma, 0.8, those don't change. The x is the only thing that changes now. 1 in this part. Whoops, I've got a syntax. Let's go to it. Got 2 commas. Enter. Okay, so I'm getting 3.58 times 10 to the negative 4. Which would be 0.123. I'm going to need 3 zeros and then the 358. Okay. All right. And with the table, you would get a 0 plus on that, so a very small positive number. All right. In C, the probability, this time we want to find the probability that fewer than 3 of the selected adults watch primetime TV. So we want 0, 1, and 2. Fewer than 3 would be 0, 1, or 2. So with the calculator, this is a little bit different. This time we want to go to second vars, and we're going to come down to that other, the CDF, because it's cumulative. Whoops, I went too fast. I want B. Let me double check and make sure I'm doing these in the right order. Alright, CDF, I want to go from, okay, N, P, and X. Okay, so N again is 7. P is 0.8. And this time, when I do this, it gives you 0 through whatever number I put in here. So since they said fewer than 3, so I want to go through 2. Oops, backspace. Alright, let's try that again. Okay, second vars, and I want B. Scroll down to B. Whoa. Okay, enter. And I want 7, comma, 0.8, comma, 2, and close it. And I'm getting 0.00467. 0.00467. So let me put that here. Probability X is less than 3. And again, for the book, it's going to give you 0.004, which is slightly different from what we got with the calculator. If we randomly select 7 adults, it is an unusually low number for those who watch primetime TV. And so the answer is yes, because of the fact that probability is less than 0.05. And if we look at part C, actually it's not much better when you consider 0, 1, and 2, and that's really the part we want to look at. So D is yes, it's unusually low. Certainly that probability again is less than 0.05. Alright, for 32, we're going to go to stat disk. So let me start that up, coming up while I'm okay, and let me kind of move